Manufacturing organizations have always needed a way to measure the overall quantity and quality of products leaving the factory in order to quantify the overall productivity of the organization. Quality systems have used the concept of yield since the early days of the Industrial Revolution. In general, yield refers to a passing rate for completed parts that are free of defects as measured against customer specifications. However, the way we measure defects and calculate yield can give strikingly different results. Let's examine 3 different kinds of yield. Classical yield is the number of defect-free parts for the whole process divided by the total number of parts inspected. It does not show which of the many potential sub-processes may be causing specific problems. It also does not take into account rework, which may take place within a complex process. Therefore, valuable data is lost. Click on Next to look at the next type of yield. First-time yield is the number of defect-free parts divided by the total number of parts inspected for the first time. This is a better yield estimate to use in driving improvements. Click on Next for the final type of yield. Throughput yield is the percentage of units that pass through an operation without any defects at any stage. This is the best overall yield estimate to use in driving improvement to a process, and is closely related to the defects per million opportunities value in Six Sigma. For additional information on these 3 types of yield, including examples and calculations, click on Tell Me More on the left menu. Otherwise, click Next. In this step, we examined a number of topics. These included key statistical measures used to determine variation, the values generated for continuous and discrete data, visual displays of data including histograms, normal curves, and other displays produced by Minitab, the concepts of process capability, variation, and yield, and examined the use of the Process Capability Report and the Product Report. So where are we now with the commercial loan case? Well, we have now defined the process capabilities, which established our baseline for the process. It seems apparent that we have a process in serious need of improvement. Congratulations! You have completed Analyze Phase Step 4. You have clearly defined the capability of your process. Before we go on to Step 5, feel free to use the resources in the left menu to review any of the material you wish. When you are ready, click Next to continue on to the next step. Now that we know where we are starting from, we can begin to determine our performance objectives, or where we want to wind up at the end of the project. So in this step, we're going to determine our performance objective. Click Next and we'll look at the learning objectives for this step. Remember that in Step 4 we determined our current process performance, as well as a number of other factors. Here, in Step 5, we'll use some of the results calculated in Step 4 to determine what the end results of this Six Sigma project will be. After you have finished with this section, you will be able to define benchmark, entitlement, and baseline, and explain how you determine a performance objective. So when you're ready, click Next and we'll move on. You must understand where you are starting. The starting point is called the baseline. It is the point at which measurement of improvement will begin. The process entitlement is the best that can be accomplished with current technology. The usefulness of this concept is that it will indicate whether or not you need to consider new technology in order to complete your project. Technology is a fairly broad term in this context and can include new tools, parts, and other key resources. It can consist of materials, skills available, equipment available, communications infrastructure, or even an accounting system. It's an extremely broad term. Click Next and we'll look at our third term. While the baseline identifies where you are and the entitlement shows what can be expected with current technology, the benchmark is the current best practice. Benchmarking is defined as a process for identification of best-in-class practices and standards for comparison against internal practices. Click Next and we'll take a more in-depth look at this critical activity. Benchmarking is a continual search for the best practices, methods, and processes. The aim is to adapt the best features of these benchmarks, no matter where they originate, and use them to make our own processes and products the best of the best. There are three primary sources of best practices: the top performers within GE, top performers among our competitors within the industry, and top performers in a similar situation in any industry. All of these sources should be examined whenever possible. There are three keys to success in benchmarking. Consider all organizations, not just corporations. Look at all sectors, including government, non-profit, and hybrid organizations. Corporations don't have all the answers. And look at both domestic and international organizations. If you want to read more about benchmarking, click Tell Me More. Otherwise, click Next to take a look at some further analysis of the commercial loan process. The overall DPMO for the application data entry process is over 217,000 defects per million opportunities as defined earlier. So how much should you look to reduce this value for your project? There are new corporate guidelines for Six Sigma certification. Please check with your business quality leader or master black belt for help understanding the requirements in your business. Let's assume for the moment that your guidelines say to reduce the DPMO by 90% to start. If the actual DPMO is over 217,000, how feasible is it to consider reducing by over 90% to near 20,000? One way to get a quick reality check is to look at the short-term PPM or DPMO. This is a close approximation of the process entitlement. As you can see, this value is still over 57,000. Reaching 20,000 with the current process technology is highly unlikely. This gives us a hint to what kind of changes may be required. Click on the underlined text if you wish to see the glossary entry for process entitlement. However, we have another value we need to look at before we can truly set our performance objective. This involves comparing our process to that of a competitor through benchmarking. Click Next to continue. We were able to acquire data from a competitor as part of our benchmarking process. According to our limited data, our competitor has been able to show a long-term defect rate of a little over 40,000 defects per million opportunities. The goal should be to at least catch up and, if possible, exceed competitor performance. The long-term goal is always to achieve Six Sigma performance. So we have tentatively set our performance objective for the data entry process at a long-term DPMO of less than 40,000. Click Next to continue. Short of our goal. This implies that our current process is not very competitive, and even our process entitlement falls short of our goal. This implies that we may need a radical change in our process, including the implementation of new technology to meet our goal. Through a discussion with the team, we have determined to set the goal to reduce the DPMO from 217,000 to no more than 40,000, with the intention to reduce this DPMO further so we can reach Six Sigma and delight our customer. Click Next to continue. We still have the issue of our benchmarking study defining a performance objective that exceeds our process entitlement. What does this mean? Here's a hint. The answer is in the glossary definition of process entitlement. When you have selected your choice, click Done to continue. Correct. The definition of the process entitlement says that it is the best the process can do with current technology. So as we progress, look for a technology in the process that may be changed. Click Next to go on to the Step 5 summary. We still have the issue of, in this step we used benchmark, entitlement, and baseline in the context of business strategy to assist in our goal setting. The team set the project objective in consultation with black belts and master black belts. In this case, exceeding the competitor's process is the minimum goal. Improvement is measured by reduction of the actual DPMO number. This is the metric that will determine the success of your project. Remember to check out all of the resources that provide additional information on the topics of this step. Click Next to continue. So where do we stand with our commercial loan case? Due to a discussion referencing the process entitlement and the competitor benchmark, we intend to reduce the long-term DPMO of the application data entry process from over 217,000 to under 40,000 defects per million opportunities. Because the performance objective DPMO is less than our estimated process entitlement, we will look for a change in process technology, which could include new forms, a change in style, or other systematic changes to the application and/or the way we enter the data. Click Next to continue. Well, you've done it again. You've finished Step 5. We've only got one step left in the Analyze phase. So if you're ready, click Next and we'll go on. If you decide to leave now and come back later, you can go right to Step 6. Don't forget to check all the extras in the Tools, Resources, and Glossary menus to the left. See you in Step 6.